Hello, and welcome to AP Physics C Mechanics AP Review with Satch. The other guy on the channel who'll be doing videos, his name is Arya, and he will be focusing on AP Physics 1. And don't forget to like and subscribe if you found the video helpful. And if you have any further questions, there will be a Discord server in the description. You can go ahead and click and join. Alright, so 1.1. Kinematics. Kinematics is a relatively easy unit compared to the others, and it's the fundamentals of physics. So let's first focus on a key distinction in kinematics: a scalar value and a vector value. So if you've taken previous math classes, like pre-calc or algebra 2, which you've had it taken to be in physics C, you know that a scalar only has magnitude and a vector has both magnitude and direction. So examples of a scalar would be like time or energy. So time and energy, you can have a lot of time, you can have a lot of energy, you can have no energy, or you could have minimal time. But you cannot have time northeast, or you can't have energy at 30 degrees. You have energy and you have time, or you don't have energy, you don't have time. So the point is, these values have no direction, whereas examples of vectors such as velocity or a force has both magnitude and direction. So like you can go 5 meters per second in that direction, you can go 2 meters per second over here, and you can have 5 newtons of force going that way, or 5 newtons or 10 newtons of force going that way. So the point is, in a scalar quantity you have no direction, whereas a vector quantity has direction. So in kinematics, we have 4 important variables which have their which some of them have their scalar and vector counterparts. So the first is time, which we all know about. In physics, it's commonly denoted in the units of seconds. And here we have displacement or distance, in which the displacement is the vector, whereas distance is the scalar. So a key distinction in where these differ is, let's say you're at point A and you want to go to point B, and point A to point B is 10 meters. If you were to go from point A to point B, your displacement and your distance would be 10 meters. But if you went from point A to point B back to point A, your displacement would be 0 meters, whereas your distance would be 20 meters. Why? Because your displacement is only concerned about where you started and where you finished. You started at A and you finished at A. So you made no actual displacement. But distance is concerning more than just where you travel. So distance could be you go from point A to point B all the way back to point A. That would be a verbal way of describing distance. Where displacement, you started at A, you ended at A. So your displacement would be 0 meters, your distance would be 20 meters. Similarly, if you're in a circular track with radius of r, then your displacement, if you go from here and you do 1 revolution, your displacement would be 0 meters, because you started at that spot, at that dot, and you ended at that dot. So you made no change. Whereas your distance would be you went around the whole track, which would be a distance of 2 pi r meters. So that's displacement and distance. Similarly, you have velocity and speed. Velocity is your change in displacement over change in time, or commonly denoted in calculus as the time derivative of displacement. And your speed is the same thing except there's no direction, so it's only magnitude. Which also means it can't be negative. So, just for a quick example, if you went from point A to point B, which is 5 meters, if it took you 2 seconds to do so, then your average velocity would be your displacement over your time, which would be 5 meters over 2 seconds, which would be 2.5 meters per second. And as you can see, the units are meters per second for velocity. Now, another way they could test this in Physics C is they give you a equation for velocity or displacement, and they ask you to find the other counterpart. So let's say you had v of t is equal to t squared. Then if they ask you to find the expression for the displacement, you know that if v equals dx dt, then x of t is equal, or a better way to say it, your change in x would be the integral of v of t dt from time t equals 0 time t equals 2, for example. Let's say they wanted to say that how far did you go in the first 2 seconds. So if you integrate this function, you would get x of t is t cubed. And then you know 0, it would be 2 cubed. You plug in the bound, so 2 cubed minus 0 cubed is 8 meters. So that's a common way they'll test you, is they'll give you an expression and they'll ask you to find the other expression in which you have to do a derivative or an integral. The last very important variable before we get to practice problems is acceleration. And acceleration is your change in velocity over change in time. Let me erase this real quick. So your acceleration is your change in velocity over your change in time, commonly denoted in calculus as the time derivative of velocity, or the second derivative of position. So units for this would be meters per second squared, or an easier way to understand it would be meters per second per second. And let's say that your acceleration is 10 meters per second per second. This would mean that every second your velocity would be increasing by 10 meters per second in that direction. So in the first second, you'll be 10 meters per second. Then at the next second, you would be 20 meters, then 30 meters every second, etc. So another example problem I could give you in Physics C is where they give you v of t as this function of t squared, and they ask you to find what is a of t. In this case, you know that a is dv dt, so you find the time derivative of t squared, and that is 2t. Right, so these are the fundamentals of kinematics, and what the kinematics is using these variables to calculate an unknown variable in a problem. So now that we know the variables of kinematics, we now have to learn the kinematic equations. These equations are how you use certain variables to find unknown variables. So there's 3 important equations. We have the final velocity is equal to the initial velocity plus acceleration times time. Then there is the final velocity squared minus the initial velocity squared over 2 times acceleration equals displacement. And then we have displacement is equal to the initial velocity times time plus 1/2 times the acceleration times time squared. So these are 3 key equations that we're going to use, in which we're going to use these equations in scenarios and problems where you have known variables and you're trying to find unknown variables. So now let's go into the practice problems. So for our first example, we will do Bob dropping a ball. So Bob drops a ball and it goes a distance h. We want to know how long did the ball have in flight, and we want to know what was the final speed of the ball when it hit the ground. So first, in kinematic problems, you want to first figure out what you have and what you're trying to find. So what we have is we know that Bob dropped the ball. the wording of these questions is very important, like rest or dropped, because that could implicitly give you variables. So in this case, if Bob drops the ball, we know that the initial speed of the ball was 0 meters per second. Then we know that its displacement is h. And we also know that the acceleration is negative g, which is the acceleration due to gravity, which is equal to negative 9.8 meters per second squared, which is on your equation sheet, so you don't have to memorize it, but at some point, if you do enough problems, you'll just end up memorizing these anyways. So we have these three variables, and we're trying to find these two variables. Let's start off with final velocity. So if we use, let's look at this equation. We do not have the final velocity, we do have the initial velocity, we have the acceleration, but we don't have the time. So in this equation, you have two unknowns, so you can't use this equation right now. Let's go to the second equation. Well, you don't know the final velocity, you know the initial velocity, you know the acceleration, and you know your displacement. So in this case, we know 3 out of the 4 variables in the equation, so we can manipulate it to find the fourth variable. So let's use that equation. We know that we don't know what v final is, so let's do it. V final squared minus v initial squared, which is 0, over, this is not negative, this is positive. Why is this positive? This is important. Why is this positive? Well, it's because the acceleration is downward, and the displacement is also downward, and in the problem, it defined the height as positive, because it said it went a displacement of h. Which means that we need to assume that since h is positive, and down was positive, thus down was positive, the acceleration has to be positive in that case. So we know that the acceleration here is 2g, and that is equal to h, which means if we rearrange the variables, you get that the final velocity is equal to the square root of 2gh. Now we know what the final velocity is, we know what the initial velocity is, we know what the displacement is, and we know the acceleration. So now let's try to find time. Let's go back to the first equation. In the first equation, we know what the final velocity is, we know what the initial velocity is, and we know what the acceleration is. However, just for the sake of this video, I'm going to go to the third equation here. Because imagine if you were asked to find the time, but not the final velocity. Or if they didn't care about the final velocity. Well, in that case, you'd want to use this equation, because here you have 3 variables, initial velocity, displacement, acceleration, all in the equation, and you don't have time. So let's use this equation to be more versatile. So you know that your displacement is h. Then you know that the initial velocity is 0. So this entire term goes to 0. So then we know that the second term, 1/2 g t squared. So now rearranging the variables, you get that the time in flight of the ball is 2h over g. So now this is an easier example in which we calculated the final velocity of the ball and the initial velocity of the ball. And the time it took for the ball to hit the ground. Notice how this problem would have been much, much harder if we did. In fact, you couldn't do this problem if you did not know the initial velocity. And how do we know what the initial velocity was? Through wording. So it's very important to read the question. Now let's go to example 2, which will be a little bit harder. For example 2 here, we have Bob again, and Bob has 2 balls. The first ball he drops is ball 1. And he throws at a time later. He throws ball 2. Now he only throws ball 2 once ball 1 reaches half of its height, and we need to figure out at what speed does Bob need to throw the ball in order for both balls to hit the ground at the same time. So taking a physics problem, we need to go very you need to break down the problem, right? So let's start off by focusing on the kinematics of ball 1, specifically for half its displacement. So let's call this time that the ball 1 is in travel t1. In this time t1, we know that the initial speed is 0 because the ball is dropped. We know that the height is h over 2, and then because half the height, and then we know the acceleration is g. So we know, using the kinematic equation, delta y equals v naught t plus 1/2 at squared. The v naught is 0, so this term goes to 0. You know delta y is h over 2. And we know that a is g, so 1/2 gt squared. So we know that t1 is equal to the square root of h over g. All right, so let me write that over here, square root of h over g. And let me provide myself with some more real estate. So now let's figure out the total time it takes ball 1 to hit the ground. So that'd be time t. In time t total, the displacement is just h instead of 2h. It's h instead of 1/2 h. So this time here, not that. This whole time here, t total is equal to the square root of 2h over g. You would do the same process again, but instead of delta y being h over 2, it would be just h. So now we have to do that another extra step. And the point here is that we know that time t1 is root h over g. And we know that once the ball is at the height h over 2, only then does Bob throw the other ball. And both balls hit the ground at the same time. So this time here, between when the ball goes from half its height to the full height, let's call it t2. We know that t2 is going to be the time that ball 2 takes in its total flight. And we know that time t1 plus time t2 is time total. Solving for t2, we get that t2 is equal to t total minus t1, which is equal to, let me erase this real quick, is equal to the square root of 2h over g minus the square root of h over g, which, if you simplify it, is the square root of 2 minus 1 times the square root of h over g. So we know that time t2 is equal to the square root of 2 minus 1 times the square root of h over g. Now, given the variables we have in the kinematics of ball 2, we can use this equation of delta y is equal to v naught t plus 1/2 at squared in order to find v2. So delta y is h, v naught is v2, the time is the square root of 2 minus 1 times the square root of h over g plus 1/2 g times root 2 minus 1 squared times h over g. I just mentally did the square in my head for that. That's how this t squared becomes that. So then the g's here cancel, and you subtract this right term on the left to get h minus h times the square root of 2 minus 1 squared over 2 equals v2 times the square root of 2 minus 1 times root h over g. Factor out the h times 1 minus the the square root of 2 minus 1 over 2 squared over the square root of 2 minus 1 times the square root of h over g is equal to v2. And that is your final answer. Now, if the question just asked for v2, this would be totally enough to leave your answer. You don't have to simplify it anymore. Now, if the question asks you to find some functional dependence between like h and v2, then you would want to move the radical up just to get a clear relationship between h and v2. But yeah, this is how you do the problem. The key hard part here is figuring out what T2 is, this part, with the T1, T2, T-total approach. And that type of thinking is going to be what's needed in this class. And that's that. So if you like the video, hit the like button and subscribe. And if you have any questions about example 2, example 1, or any examples in any of the videos you've seen, just join the Discord server and we'll be happy to answer your help. Have a nice day. Thank you.